Very good.
All right, example number one of solve by factoring. Now, you may not recognize this type, but that's okay. We're going to do the first step. In the class notes, there's a list of steps to follow. Step one is always to set it equal to zero. Sometimes it will be equal to zero, but this one is not. So I have to make sure that whatever is on that side comes to this side. And you want to put that bad boy right there. Now remember, these are not like terms. There is no way to subtract x from x squared. Now on that side, I have equals zero. That's step one, set it equal to zero. Now it's about recognizing what type this is. Type 2 is trinomial, which is three terms. This does not have three terms. Type 4 also has three terms. That's perfect square. Type 3 is a difference of perfect squares. Now you might think, ooh, 16. But 24 is not a perfect square. 25 is a perfect square. So this cannot be type 3 because this is not a perfect square. So what you look for is, do these terms have anything in common? Well, yeah, they do. 16 and 24 are divisible by a common number, and you have x2 and x1. So now take the 16 and write all the numbers that divide it. These are the only numbers that divide 16. 16 is not divisible by 3, 5, 9, 10, and so on, so forth. So now compare them against 24. 24 is divisible by 2, yes. But it's also divisible by 4, so he's done. It is divisible by 8, so he's done. 24 is not divisible by 16. So my greatest common factor is going to be 8. And then you have x squared and x1. You take the smaller one, so 8x. This is my greatest common factor. So that's how you factor it, right? This is type 2. I'm going to put the GCF of 8x in the front. Now 24 divided by 8 is 3. X squared divided by x is x, right? 8 times 3, 24. X times x, x squared. You're doing the reverse. 16 divided by 8, you have a negative there, so it's 2. X divided by x, the x is crossed out. If you put an x here, x times x is x squared. That's not what you have. Make sure. Negative 2 times 8x is negative 16x. So I know I factored it right. Equals 0. It's very important this is there. Why is that important this is there? Because if the product of two things, remember this is a product. If the product of two things is 0, one of them must have been 0. So either 8x is 0 or, put a squiggly, 3x minus 2 equals 0. If you multiply them and make 0, one of them must be 0. This is your big step. Now, I'm going to do this one first real quick. Add 2 to both sides. So you get 3x equals 2. Divide by the 3, and show it. So this answer, I get 2 over 3, 2/3. Boom. Now, over here, I want to show you a couple of mistakes I see. The first thing I see is people do this. This one's my favorite. This is 8 times x. This is a product. The opposite of multiplying by 8 is not subtracting 8. So this move is complete nonsense. All right. So most people actually do this part correct. But then they write some weird stuff down. Well, first of all, they'll write 0 over 8. You can't leave it like this. You have to tell me what this is equal to. Now, some people will just say, oh, 0 over 8, 8. This is nonsense. 0 divided by 8 is not 8. So that's out. And those people, oh, this is undefined. So I'm going to write BS. And no, it's not undefined. 0 divided by 8. Real simple. What number times 8 makes 0? There's only one number it can be. So this answer, you have to tell me that x equals 0. You can't leave it as 0 over 8. So this was the very first one. Set it equal to 0, because it wasn't. Factor it, and then set each individual factor equal to 0 and solve them separately. And I get 2 answers, okay? So this is the first solve by factoring. All right. Second example, solve by factoring. Now, this is not type 1. How do you know? There's no greatest common factor. There's no number that divides 16 that divides 81. They don't have a letter in common, so type 1 is out. This is not type 2 because it's not a trinomial. Type 2 has 3 terms. This only has 2. Now, type 3 is a difference of perfect squares. It is a binomial. Perfect square, perfect square. Now, step 1 says set it equal to 0. It's already equal to 0. So I'm going to jump to step 2, which says to factor. Now, how do you factor it? something times itself. 4x times 4x is 16x squared. Now I need to make 81. So again, something times itself. So that's going to be 9. And now you make the signs different. One guy gets the plus, one guy gets the minus. So this was step 2 in the list of steps. Set equal to 0, factor. Now step 3 says take each factor. If the product of two things is 0, one of them must have been 0. So either this one is 0, or if you want, put a little squiggly line there, the other dude is 0. Now, here I'm going to subtract 9, and then I'm going to divide by 4. Make sure I do this right this time. So you get x equals -9 divided by 4 on that side. Here I'm going to add the 9. And again, I'm going to divide by the 4. So you get positive 9 over 4. So those are my two answers. If you want to be more fancy and sophisticated, you can write it like this, because I have 9 over 4 is the same. So you can write it like this if you want. You can write plus or minus 9 over 4, because I have a negative 9 over 4 and a positive 9 over 4. So that's fine. Or you could leave it like that. So again, set it equal to 0, it was already done. Factor it, set each factor equal to 0, and then solve. Third problem, solve by factoring. Now, this is going to end up being a trinomial. 1 term, 2 term, 3 term. So, and there's a 1 in front. So this is going to be type 2. There's no greatest common factor here. So the first step is to set it equal to 0. So I got to take this 12 that's there, and I have to do minus 12 to both sides. You want to put it in the place that it's supposed to go. It's supposed to go at the end. So put it at the end. Now, step 2, factor this. We spent a lot of time talking about signs and pairs. This sign goes first. This sign I dropped to here. This sign, because I have a negative 12 here, I can't put a minus there. A minus times a minus is positive. So the sign that I put at the end has to be plus. And then again, if you need to write all the pairs down, you can write the pairs down. I'll write them kind of quick. 1 and 12, 2 and 6, 3 and 4. These are the only pairs of numbers whose product is 12. Now, the signs are different, so you got to subtract them. 12 and 1 make 11. 6 and 2 make 4. 3 and 4 make 1. Aha. So that's got to be my pair. 3 and 4. You put the bigger one first. Remember, you have to make the middle. The middle has to come out. -4 plus 3 makes a -1 in the middle. So I know I'm good. Now, if the product of two things is 0, step 3, one of them must be 0. Now, this part's pretty easy. I mean, once you get here, add 4. I mean, if I have to show it. I mean, you're supposed to show it at this level, and then subtract 3. I mean, you shouldn't screw up at this point. Famous last words, right? So set it equal to 0, factor it, set each factor equal to 0, and solve. This has to be here. Remember, this is an equation. If you decide at some point that you don't want to leave that there, this is a completely different thing. This is not an equation. There's nothing to solve for here. So you have to make sure that you keep this there. Okay, this is very, very important. Don't lose this, or you can't do this. You can't go from this step to this step without that equals 0 there. So it's very important that it's there. So this is the final example of solve by factoring. So again, this is going to be a trinomial. 1 term, 2 term, 3 term. So step 1 says to set it equal to 0. Now you're going to be super careful here. I know that the opposite of -7x would be to add 7x, right? I need a 0 there, so I have to do whatever the opposite is. But I want you to see that if I just mindlessly take this and put it at the end, I mean, look at how ridiculous this looks. I mean, what the hell are you supposed to do with this? This is not the way that I'm supposed to see it. I'm supposed to see x2, x1, none, right? X squared and x, and then a number. So you don't want to put it there. You got to put it where it's supposed to go. It's supposed to go over there in the middle. So I'm going to write it in the place where it's supposed to go. Can you still get it right if you don't write it correctly? I mean, if you're really good, you know what you're doing. you're probably not going to do it right if you don't write it correctly. So you want to write it in the proper form. So when you eliminate him from that side, you do plus 7x. He's going to go in the middle. Now step 2 says to factor it. Let's see if we can do this one a little quicker. So we're going to put x and x. This sign goes first. This sign must be different. How do I know that? I have a negative 30. A positive times a negative is a negative. So let's see. 30 is divisible by 2. It's divisible by 3, and it's divisible by 5. We've got a lot of them. Let's subtract them really quick and see when we get a 7. Why do I subtract them? Because my signs are different. If my signs were the same, I would add them all together. So let's see, 29, 13, 7, and 1. 7. I got my winner. What do you check real quick? Positive 10 take away 3 is positive 7. If you put the 10 here and the 3 here, you're going to get a negative 7. You have to make sure the bigger number goes here. Now, one more time. If the product of two things is 0, one of them must be 0. So set them equal to 0. And then let's skip here. Subtract 10. Be a little more sophisticated. Add the 3. Those are your answers that work. Now, I'm going to show you. I'm going to check in a minute. I don't want to record the check, but you can put these numbers back into the original equation, and you'll see that it's going to work. In fact, I'm going to show you that it works. In fact, you know what? I will record it. Look, if you put negative 10 up there, negative 10 times negative 10 is 100, okay? And 100 take away 30 is 70. Now take negative 10 and go put it on the other side. Negative 7 times negative 10. A negative times a negative is a positive. 7 times 10, 70. Oh, son of a bitch, it worked. These numbers, if you put them back into the original equation, they work. These are solutions. All right, so you don't need to check this. All right, in fact, I don't want you to check this because you might check it wrong and then think you made a mistake. But these numbers work in the original equation. That's the whole point of solving, is to figure out the solution to the original equation. So first I set it equal to 0, then I factored it, then I set each factor equal to 0, and I solved.